Hey, welcome back. And so now we're going to be talking about more the local behavior. We've been talking about the end behavior, which is determined by the highest power of x, the degree of the polynomial. But now we're going to be talking about the local behavior. The local behavior is influenced by the zeros of your function. The zeros determine how many turning points or what's happening in the more local interior of the function. Now this tells us a lot about the function right here. See the x plus 3 cubed and x minus 2. So our biggest question is, when is this function 0? And the answer is, well, the only way to make a product of numbers 0 is for one of them to be 0. So the choices are x equals minus 3 and x equals 2. Those are the zeros of the function. Whereas if you put a negative 3 in here, negative 3 plus 3 is 0. And 2 minus 2 is 0. And so those are the zeros of the function. This will make this function 0. Now, x plus 3, that factor occurs 3 times, so we call that multiplicity. The multiplicity of that 0 is 3. But whereas the x minus 2, it was only represented one time, a single factor, and so we'd say it has multiplicity 1. So that's a little bit about zeros and multiplicity. Now, here's just another one right here. This doesn't have a 0. Remember, this affects the end behavior. This is actually the leading coefficient, and it is not a factor in our zeros. So let's look at the other factors. So you see all these x plus 3s? That's all the same factor. That is, I've got my leading coefficient. Those factors can be written with a single exponent of 3. So we've got 3 linear factors there. Then you have a that add up to a cubic, and then you have a 1 linear factor, x minus 4. So the zeros for this problem, minus 3 and 4, that up front minus 3 doesn't produce a 0. The smaller of the zeros, if you put a minus 3 right here, you get a 0. So this is considered the smaller one. And this one is the larger of the two roots, or we call them zeros. They're also called roots of the equation. So in this section, we call them zeros for the most part. We're talking about the zeros of the polynomial function. All right, the smaller 0 has multiplicity 3, and the larger 0 has multiplicity 1. All right, let's do a little bit more. So it says find the zeros as polynomial functions, state the multiplicity of each. Now this one has a little tricky part at the front there. That x to the 6th is actually x plus 0 to the 6th power, or x minus 0 to the 6th power, whichever one you want to do. Then you have the squared and the x plus 7. So still our question is, when is this 0? Well, the answer is when x equals 0. So you just want to choose the value of x that makes that factor 0. Choose the value of x that makes that factor 0, which would be 5. It's the opposite. If 5 minus 5 is 0. And then minus 7 would be our last 0. So the smallest 0 would say is minus 7. The middle 0 is 0. And the largest 0 is 5. The multiplicity of the minus 7 is 1. The multiplicity of the middle 0 is 6. That x to the 6th is describing x plus 0 6 factors, 6 times. That factor shows up 6 different times. And the multiplicity of 5 is 2. All right. Let's do another here. We're just rolling along here. That's that leading coefficient. Be careful with the leading coefficient. It doesn't affect the zeros. So let's rewrite the whole thing. So the negative 4 doesn't affect the zeros. The x minus 3 squared, that has multiplicity 2. X plus 2 cubed, that has a negative 2 multiplicity 3. And then you finally have an x plus 0 to the 4th. That's a 0 of 0 with multiplicity 4. The 0, 3 has multiplicity 2. Remember, we're setting this equal to 0. We're asking that question. X equals 3 minus 2 and 0 are the solutions. The blank is a 0 of multiplicity 3. That would be a minus 2 is a 0 of multiplicity 3. So multiplicity 3 there. 3 had multiplicity 2, and the 0 has multiplicity 4. Just an important little note, the sums of all your multiplicities will be the degree of your polynomial. So this polynomial has degree 4, plus 3 is 7, plus 2 is 9. Degree 9, and the multiplicities make up, if you add them all together, will give you the degree of your polynomial. The remaining 0 is 0, and it has multiplicity 4. All right, that's it for now, and we'll come back and do some of these graphs of polynomials and their local behavior. Thanks for watching.